In this example, I have a sheet metal part or plywood using the sheet metal tools, and I would like to get the flat patterns for these two components. Now if I look at this from this view, we see that there's a curve along here, also a curve on here. This face and this face are not parallel. There's actually an angle on one of these faces. It looks like these two faces are parallel. If I come over here to my flat pattern, so I see that the flat pattern for this component didn't work, while the flat pattern for this component did work. So if I go to that component, make it active, and I make that flat pattern active, so this one does flatten out. Now one consideration we need to make on this is that when we set up our sheet metal styles, we need to put a K factor of either 0 or 1, depending on whether you are using your driving dimensions from the inside of the bend or from the outside of the bend. And you'll have to do some testing to figure out which one you want to do. If we use the normal sheet metal 0.45 or 44, it's calculating bend allowance that the part is stretching, and so it's going to make the part a little bit shorter knowing that the part will stretch. So with the plywood material, again, this K factor will be either 0 or 1 depending on which side you are unfolding it from or using your dimensions to model the part. So our problem then is, how do we get this part going around here in this loop? How do we get that flattened out? And we'll have to take this over into Autodesk MeshMixer in order to unwrap that. But first let's look at how I created the part itself. So I'm going to go back to the first sketch, and I'll edit that sketch, and I make sure that I fully define my sketch. And so everything should be black. Now these offset splines are not showing in black, but if I try to drag them, they don't move. So that happens sometimes with offset splines. I don't know why this one is showing as fully defined, the others not. But the first thing I do when I'm creating a sketch is I fully define my sketch. Make sure that all of the geometry is black, and that if I need to change any dimensions, I can just double click on that dimension and change it. Now it really bothers me to see dimensions like this 29.77 or this dimension or this dimension. I'm expecting with the metric, or actually this is in inches. In any case, I'm not expecting to see what I would call strange dimensions. These are the types of dimensions that I would expect to see. 3 inches, maybe the 2.3, 2.4. Now these are weights on the splines, on the handles. But in any case, I used the dimensions as close as I could to what was given in the original problem, and then they can always be edited. And then in my sketch number 2, again, I fully defined the sketch and I tied it into sketch number 1. Everything's black, it's all fully defined. Alright, if I go back through the history then, so those were my first 2 sketches. There was sketch number 1, there was sketch number 2, and then I created some surfaces, and so I extruded these 2 inside surfaces, and then I extruded this curve and this curve as surfaces, and these are for trimming purposes, so I'm going to use these surfaces to trim each other. And then I go through that trimming process. So I trim the outside of that. I made another trim in here someplace, the inside of this, and then I did another trim, and I'm going to, we'll see here in a minute where I got to. I trimmed again, and I put a sketch in here to trim a piece out that goes through here. We'll look at that in a minute, so I'll do a trim with that. Now let's turn off the visibility of some of these surfaces that were used for trimming. So I'll turn off the visibility of this surface and this surface. So I use the other surfaces to trim off these surfaces, and then I use this sketch. It's a thin rectangle. I use that to trim a rip in this part so that it can be unwrapped. I've also laid out where the holes will be in the future once we get our parts made. And so I have those sketches, and then I'll go to the next step, and I converted the first part into a sheet metal part. And so let's turn off these surfaces, and I'll make this my active part. Before we go to the next steps, I almost forgot an important consideration. We can't make perfect parts in the real world. So if you try to model perfect parts, you're always going to be doing hand finishing to get things to fit together when you start making the real parts. So one of the things that I did here, and I almost forgot to explain that, is I offset that inside of this piece by a small amount so that this part that goes inside of that is slightly smaller than this hole. That way we can fit these together easily without having to do hand finishing. Now for the amount of that gap that you put in there, you would have to determine how big of a gap to put in there based on your manufacturing experience, understanding that we cannot make absolutely perfect parts. So really the perfect part is to include realistic clearances between components based on our manufacturing tolerances in our assembly process. And I need to go a couple more steps here till I have that. So I'll go to the next step. And so I thickened that surface. And so here's my solid body. I thickened the next surface, and I converted these then to sheet metal components, and then I did the flat patterns. So the flat pattern for this worked. The problem is for this part it doesn't work. So let's turn off the visibility of the solid bodies. I'll turn off the visibility of the sketches, and let's go back to these two surfaces. Again, this surface worked, so we don't need to worry about that one. This is our part that we had trouble with, and so we'll take this over into MeshMixer and see how we can unwrap this. To get this into MeshMixer, I need to save this as an STL file. So I'll right click and I'll then do a save as mesh, and I put it on a STL format, binary format, and I want the model was drawn in inch units, so I'll select inch units. And we have to be careful about the units because STL is actually unitless, but it determines, it does the calculations for us to get the correct size. I'll say okay to that, and then we'll go to MeshMixer. And so I'll go to MeshMixer and I'll import that, and I'll bring in that STL file. And so here we see our imported. Now this is just a single surface. There's no thickness to this. That part of the key to this is you want the surface body with no thickness. And then I'll go to edit, and I'm going to select unwrap. And so here we see it unwraps that part. I'll say accept that, and then I have a choice. I can keep both the original body and the unwrap, but I'm going to tell it I want to delete the original, and that leaves me with just the unwrap. Okay, then I'm going to export this. So I'll do file. Now I had to make sure that I select this first, and then I'll do file export, and I'll give this a name. And so let me call this unwrapped loop. Once I've done that, then I can bring this back into Fusion 360. Now remember I said that STL files are unitless. I need to make sure that my original or my starting document then in Fusion 360 is set to my desired units, and then don't do file open. Instead go to insert and tell it to insert a mesh file, and I call this unwrapped loop, so I'll select that. I'll say open, and then if I want to move things around whatever, notice it's set to the inch file type. I'll say okay to that. Alright, once I have this in as a STL file, then I need to get this to a DXF file for cutting. Now remember that we have a thin surface here, no thickness to this surface that's flattened out. I want to go to modify then, and I'll do convert mesh, and I'm going to put it on a prismatic conversion, and I'll select the mesh. I'll say okay to that, and that converts that into a single surface body. So if I go over here, I see now I have that surface body. To get my DXF file, I will then start a new sketch on that face. So I'll go to the solid modeling, I'll do a new sketch, I'll do P for project, select that face, so that projects that entire face. And so if I turned off the surface body then, so we have we have this face, and then I would go to that sketch, right click on that sketch and tell it to save that as DXF. So that's how to get a part that is not a standard sheet metal part, to get it unfolded or unwrapped using Autodesk Mesh Mixer.